Our second lesson today in math is on making our own line plots. So let's turn to page 597 and try the solve and share. The count of 3, read along with me. In a class of 27 students, 5 students have 1 pet, 3 students have 2 pets, 4 students have 3 pets, 2 students have 4 pets, 1 student has 8 pets. You can hear my pet in the background, and the remaining 12 students do not have pets. Are there any outliers on this data? Okay, to make our line plot, we need to first start with a nice straight line. This is going to be our number line. We need to give a title to it. So again, what we asked our friends or the other students about was the pets that they have. So we could just call it number of pets. And then we could, again, just kind of label this down here. This is also the pets. And then you need to go back to the numbers that they gave you. We had students who said 1 pet, 2 pets, 3 pets, 4 pets, 8 pets, and 0. And we do have to include 0 on our number line because we had several students who gave that as their answer. So we're going to go from 0 up to the number 8, since that was the highest option that someone gave us. Now remember, for each answer that we got from the different students, you can put a dot, which is what our book does. A lot of people use X's above their line plots. Okay, now we should have 27 dots in all when we finish because there were 27 students in our survey. Okay, 5 students have 1 pet, so above the 1 we're going to put 5 dots. Then it says 3 students have 2 pets, so we're going to put 3 dots above the 2. 4 students have 3 pets, so 4 dots. 2 students have 4 pets. 2 dots. And kind of try to keep your dots even so that you don't have 4 but it's all smushed together and it looks like less when you glance at it. We have 1 student that has 8. And then their remaining 12 students do not have any pets. So above 0 we have to squeeze in 12 dots. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I had to go in there up into the work. That's okay. Okay, so that's what our line plot would look like. Again, we have 27 dots all together, the most being above the 0. Now their question above in the solve and share would be, are there any outliers in this set of data? Do you see a number off to itself? Because remember, if there is a bunch of dots grouped together and then one lone dot either to the left or to the right, that's an outlier. So do we see an outlier in this one? Okay, if you look carefully, you'll notice 8 is an outlier because we don't have any 5, 6s, or 7s, so we have that big gap between. So 8 is our outlier. Okay, and that is how you make a number line plot. Okay, let's look at the back side. Here we can see Serena measured her colored pencils, recorded the lengths of each of them. She came down here, did her line plot for all of those lengths, a dot for each of the lengths that comes up. Started with the number line, gave it a title, said what we were measuring in. So that's a good line plot. Let's go to the bottom, and they want us to use this data that was collected to come up with a line plot. This is for the most common shoe size. So for each of these numbers in our data, we have to put a dot. So we have a 4.5, so above 4.5, put 1 dot, cross that out. 5.5 gets a dot. I like to mark them out as I go so they don't use them again. So there's 4, then we have a 6 and a 7. Then 5.5. 10, 6, 5.5, Another 6, an 8, 5.5 again, 6.5, and another 5.5. So we have constructed a line plot using these shoe sizes. Then they have a question. What is the most common shoe size? So which shoe size, it's hard to say, has the most votes? And if you look, the longest amount of dots is 5.5. So what is the most common size? 5.5. Their second question is which size is an outlier? And for that amount, that group of data, the one that's by itself, it's way down here. Size 10, because nobody else was near that. 8 was the closest, but even it was a little bit away from some of the rest. So our outlier is size 10. And again, that is how you can construct a line plot. So let's try and look at page 599. Same idea. Complete a line plot. This is showing the lengths of Sandy's pencils. So I see a 6 1/4, so I'm going to put a dot above there. Sometimes our line plots use fractions, and that's okay. 5 1/4 gets a dot. 6 3/4 gets a dot. 5 3/4. 6 3/4 again. 6 2/4. Line plot complete. Okay, I would like for you to go down to the bottom. I want you to try 4 and 5 on your own, and when you finish, turn the video back on, so put me on pause, give 4 and 5 a try, and then check your answers. Okay, if you're checking your answers, your line plot should look like this. You should have 3 dots above 6.5, 2 dots for 7.5, 4 dots for 8, and 1 dot over 8.5. Now their question is, what is the length of the longest bracelet? Now remember, they're not asking which bracelet got the most votes, but which one is the longest. The longest would be at 8.5. They were measuring in inches. What was the shortest? Again, it's not 6 because 6 didn't get any votes. It is the smallest number on the line plot, but no dots above it. So the shortest bracelet would be 6.5 inches. And that is how we would do a line plot for that data. Okay, let's look at the back side. Let's look at number 6. Is there an outlier on number 6? Look at that carefully. There is. We see a whole bunch of dots here by themselves, and we see this dot by itself. So, yes. And it is located, this is 65, so that'd be 66 at 67. All by itself, that makes it an outlier. Okay, now let's look at number 10. Here they want us to construct our own line plot, but they haven't helped us out by putting the numbers along the bottom, so we have to do that. So we need to look at our data and find the smallest number, because that's where we want to start our line plot. Okay, the smallest number is 5, so we can make that our end number on the left. Then look and see what they're counting up by. They're using fractions. It looks like they're counting up by fourths. So after 5, we'd have 5 1/4, then 5 2/4, or 5.5, 5 3/4, 6, on to 6 1/4, 6 2/4, 6 3/4, and then 7. Okay, then we're going to place a dot for each of these. Again, we're doing lengths of bracelets. We have a dot above 6, 6 3/4. So I put that in the wrong spot. I'm just going to exit out. 6 3/4, 6 1/4, 5 3/4, 5, 6. Now I need my 6 2/4, so I'm just going to put that back. 6 2/4, 6 1/4, 6, and 5 3/4. Okay, and that would be what our line plot would look like. Okay, one more page let's look at. Page 601. In 601, I would like you to try problems 1, 2, and 3. When you have those complete, turn the video back. Okay, your line plot should have ended up looking like this. So check and see if you have the dots all in the right spot for Aiden and the toy cars that he has. Okay, question number 2. How long is Aiden's longest toy car? Remember, it's not the biggest number on the line plaque, so it doesn't have any dots above it. It's the one that does have a dot, and that would be 2 7/8 inches. Which length appears most often? So who has the most dots above it? That would be 2 3/8. And then the last question, are more cars shorter or longer than 2 1/2 inches? Okay, 2 1/2 inches is right here, didn't get any votes. So do you have more dots to the left that are shorter than 2 1/2, or more dots to the right and they're longer than 2 1/2? A lot more dots over there that are shorter. So shorter is the correct answer for number 4. Okay, that is the end of today's math lesson. You do have some math problems to complete for this lesson. So I want everybody to have a great day today, and don't forget to read your AR book system.